So we can see that inside this current steering DAC, what we have is current source. And instead of directly generating an analog output with the help of current source, what we can do is, with the help of switches, we can up convert this current to the RF. Based on the digital code, then we can decide how this up converted current is going to flow to the load. So we can have this kind of load, and this is a standard double balanced kind of configuration. Digital code is being fed here. 0, 0. We can do this connection for a balanced out. So you can see that unlike the standard active mixer case, so where we have the voltage input and this transconductor converting into current, and then we use LO to up convert. Here what we are saying is we will use the switches to up convert the bias current or some DC current, and with the help of switches we can control what is going to be the final output at the RF. So the good thing about this architecture is we only have switches. There is no transconductor. So overall linearity performance is already going to improve. So if you want to add more bits, we can add one more replica of the entire circuit. It is going to be driven by this D1, and now we can decide how this current should flow at the output depending on this D1 code. And since the output is in the current domain, we can just connect their output to the first unit cell so as to obtain a 2-bit performance. Now we can see that there are no associated dedicated analog blocks other than these current sources, and depending on the number of bits we can keep on increasing the unit cells. Here the unit cells can be binary weighted. This can be 2.0, And by just adding more such unit cells, we can increase the number of bits. This is another implementation of RF-DAC, also called as the digital to RF converter. We can see that again this problem of image is going to appear, and if you want to solve the image problem, we can use oversampling of these digital bits so that the images are pushed away from the center frequency, and then it can be further filtered out by a bandpass filter in the RF domain. You can already see that if you want to do complex modulation, then we will be needing also a quadrature replica of this RF-DAC. So that quadrature replica can be just a copy of this entire mixed signal block, and the output of this Q channel can be combined with the output of the in-phase channel in the current domain by just sorting the output nodes. So the circuit is really compact, and we can see that as the technology scales, the switches are going to become even better. So the performance of these kind of reconfigurable transmitters are going to only improve with technology scaling.